Welcome to today's episode of mathematics, and we are going to look at exponents or indices. So when I write here index, the plural is indices. Yeah. So that is what we are coming to talk about. So we're coming to talk about exponents or indices. So indices or what exponents is what our topic is for today. Now, quickly, when I write a raised to the power n, this whole thing that is in this bracket is a power. It's called the power. This is called the exponent. In that case, the m is the exponent. And then this a that we have here is called the base. So together, this whole thing is a power. This alone is called the exponent. And then this is what we call the base. Alright. So to be able to solve problems involving exponents, we need to familiarize ourselves with the rules of exponent. Exponent says that if you want to solve me, if you want to know how to deal with me, then I have some rules that you need to obey or you need to observe. Once you observe those rules, you will be able to deal with me. So we cannot go simply straight away go and start solving questions without actually making reference to or familiarizing ourselves to the rules. So let's quickly look at the rules of what exponents. So we'll look at 5 major rules that we shall be applying from time to time. The first one so we call them rules, or we call them what? Laws. They are laws or rules of what? Exponents. So they are what? Rules or laws of what? Exponent. So now let's quickly look at the rules or the laws. The first one, we shall say that when we have a raised to the power m times a raised to the power n, then this becomes a raised to the power m plus n. We shall explain that. Then number 2, if we have a raised to the power m over b raised to the power n, then this means that we should have a raised to the power m, if a raised to the power n, a raised to the power m over a raised to the power n, the answer is equal to a raised to the power m minus n. Then 3, if we have a raised to the power m, okay, now, and then this is what? Raised to the power n, then this should be a raised to the power mn, m times n. Okay, now let's look at the fourth one here. If we have a raised to the power 0, then the answer is equal to 1. So any number raised to the power 0 is equal to 1. And then again, yes, so we can limit ourselves to this one for now. So a raised to the power m times a raised to the power n is equal to a raised to the power m plus n. This implies that if we have 2 raised to the power 3 times 2 raised to the power 4, the answer is equal to 2 raised to the power 3 plus 4, which is 2 raised to the power 7. That is what it means. Now, this implies that if we have, for instance, 2 raised to the power 4 all over 2 raised to the power 2, this becomes 2 raised to the power 4 minus 2. This is 2 raised to the power 2. Now with this implies that if we have 2 raised to the power 3, okay, all raised to the power 2, then the answer becomes 2 raised to the power 3 times 2. Okay, we multiply the powers. That is 2 raised to the power 6. So this also implies that if we have 45 raised to the power 0, the answer is 1. If we have 7 raised to the power 0, the answer is 1. Any number raised to the power 0 is 1. So that is what we have said. So we are going to apply these rules. This is what we call the power rule. So we are going to apply these rules in solving questions. You apply them. So now let's quickly look at some questions. So number 1, let's look at worked examples. So worked examples. 1. Evaluate simply means compute. Okay. So if we have 9 raised to the power 20, for instance, plus 9 raised to the power 20 plus 9 raised to the power 20. And we have to solve this, or we have to evaluate this. How do we go about this? So let's look at the solution. And we are going to apply the rules that we have just talked about, or the laws. For instance, and some other things that we know. If I write ax plus bx plus cx, for instance, and then you are to solve this, or you are to simplify this, what will you do? You can see that x is common to all these 3 terms that we have here. So we shall factor out. So to be x out, a plus b plus c. So that x multiplies a, we have what? Ax. X multiplied b, we have bx, plus x multiplies c, we have what? Cx. So that is it. So we shall apply this principle here. So now, you've got an idea what we need to do. So if we have 9 raised to the power 20 plus 9 raised to the power 20 plus 9 raised to the power 20, this will be equal to, something is common here. What is common that we need to factor out? 9 raised to the power 20. So 9 raised to the power 20 is common. We factor it out. So we have 1 plus 1 plus 1. Okay. So that this means that when this multiplies this, it will give us that, plus when this multiplies that, it will give us that, plus when this multiplies that, it gives us that. Okay. So now, what are we doing? This is equal to, what do we do here? Now, this 9 is big also. We can break 9 using a base of what? 3. So we know that 3 squared is equal to what? 9. then we put a bracket, we put our 20, that was there. Okay, then we bring our bracket, we add 1 plus 1 plus 1 will give us what? 3. So that gives us 3. Okay, so this is equal to, when we come here, we shall have what? 3 raised to the power 40 times 3 raised to the power 1, because there is a power of 1. All numbers have got powers, but we can't keep writing the powers. 2 raised to the power 1 is 2, 3 raised to the power 1, no. But when we are solving questions like indices or exponents, since we are dealing with exponents, we need to indicate the exponent there. So this then becomes, remember the rules we talked about. We said that if we have a raised to the power m times a raised to the power n, the answer becomes a raised to the power m plus n. The same rule we are going to apply here. So since we have this, this will be what? 3 raised to the power 40 plus what? 1. So the answer is equal to 3 raised to the power 41. So this is the answer. So you can see this one. All right. We will also be looking at another question, 2 raised to the power 0 plus 3 raised to the power 0, then minus 5 raised to the power 0 whole square. So let's clean this one and have another example, example 2. So this one says solve 2 raised to the power 0 plus 3 raised to the power 0 minus 5 raised to the power 0 all squared. This is what we have. So let's look at the solution. Now, what do we do here? The solution, we're going to look at what? 2 raised to the power 0 plus 3 raised to the power 0 minus 5 raised to the power 0 all raised to the power 2. This is equal to, we come here, 2 raised to the power 0 is 1 plus 3 raised to the power 0 is 1 minus 5 raised to the power 0 is what? Is 1 also. So 5 raised to the power 0 is 1. Now all this squared. Okay. So now this will be equal to 1 plus 1 is what? 2. 2 minus raised to the power negative 2. Sorry, this should be negative 2. This is negative 2. Okay. So now this is 1 plus 1 is 2. So this is 2 minus 1. So this is going to be 2 minus 1 raised to the power negative 2. And then this is equal to 2 minus 1 is what? 1. 1 raised to the power negative 2. What will that give us? It will give us 1. Reason why it will give us 1 is that if we have a raised to the power n, there was a rule that we should have looked at, which we didn't. We looked at 4 laws. Remember, let's take this as the 5th law. If we have, for instance, a raised to the power negative n, the answer becomes 1 over a raised to the power n. So it follows that if we have 2 raised to the power negative 3, you can write the answer as 2 raised to the power 3. Since 2 raised to the power 3 will give us 1 out of 8. So that is what it gives us. So you can take this as another rule. So that's what we are applying here. If we have 1 raised to the power negative 2, of course it's the same as what? 1 raised to the power negative 2 is the same as what? 1 over what? 1 all what? Squared. This becomes what? When we write 1 over 1, then the negative changes to be what? Positive. Now if we do that, 1 over 1 will still give us what? 1 squared. 1 squared is the same as 1 times 1. So the answer is 1. So that is why from here I wrote 1 straight away. So that is what it gives us. Now let's look at the last one, so that we continue another time. So let me wipe this. So let me clean it quickly. Let's look at a third example that says that if we have if we have 5 raised to the power 3n plus 1. So 5 raised to the power 3n plus 1. Okay, 5 raised to the power 3n plus 1 times 5 raised to the power n minus 3 times 5 raised to the power n minus 3. Okay, 5 raised to the power n minus 3 times 5 times 5. All these over 25 raised to the power 2n minus 4. 25 raised to the power 2n minus 4. So this is the question that we have, and then we want to solve this. So let's look at the solution to this problem. We are going to look at 5. Now we see that there is 5 here, so we have 5 raised to the power 3n plus 1 times 5 raised to the power n minus 3 times 5. Remember that once you see this 5, it means there is a 1 there. Alright. Now all this over 25 raised to the power 2n minus what? 4. Now what we're going to do is, since we have 5 here, 5 here, and 5 here, we are going to break 25 down using a base of what? 5. So this will be equal to 5 raised to the power. Now what is happening here? The bases are what? The same, and they are multiplying. So what do? We shall add their exponents. So this times this will give us what? This will give us 5 raised to the power 3n plus what? 1. Okay. Plus n minus what? 3, which is this one. Okay. Plus what we have here is what? This is what? 1. So we shall have what? 1. All these over 25 is the same as what? 5 raised to the power 2. Okay. 5 raised to the power 2, all into brackets 2n minus what? 4. This is what we have. Now this is equal to, what we shall do is, here we can decide to compute this. So this will be 5 raised to the power 3n plus n will give us what? 4n. Okay. 1 plus 1 will give us what? 2. 2 minus 3 will give us what? Negative 1. So this will give us 4n minus 1. So this will give us 4n minus 1 here. All over, we come here, we multiply out. So this will give us 5. 2 times 2 will give us 4n. Then minus 2 times 4 will give us what? 8. So this will give us 2 raised to the power, 5 raised to the power 4n minus what? 8 is what this gives us. So from here, what do? We apply the rule. A raised to the power m over a raised to the power n is equal to a raised to the power m minus n. So a raised to the power m over a raised to the power n is equal to a raised to the power. So this will be equal to, here we come here, we shall have 5 raised to the power, we subtract their bases, 4n minus 1, okay, then minus 4n and minus what? 8. And that will give us what? 4n minus 4n will cancel out, and then minus 1 minus 8 will give us minus 9. So that will give us minus 9. So 5 raised to the power negative 9, which is the same as what? 1 over 5 raised to the power 9. So that is what we shall have for that question. So thank you very much for watching. We shall meet another time and then continue from there. We shall look at various different types of questions and solve them. As we solve as many questions as we can, we will become familiar with questions like this type. So see you next time.